cluster. We're talking about AKS, right? So today we're going to look at an example of actually deploying application in AKS. What it entails? Throughout today, you're going to see basically a summary of everything we've been through, like everything we've been through throughout this series. Talk about using Docker to start up an application, using Docker how to do Docker build, how to do everything. We're going to look into that today, and we're going to at the end deploy application to AKS. That's what we're going to do today. So it's a hands-on guide. I'm going to share this for anybody that wants to follow along. You can get your Azure free subscription. I know the $200 we get last year will have expired, but I believe you can still deploy AKS, and play with it. Or if you've not gotten it, it's a time. You can use this period to just get the $200 and basically practice along. Again, like we said, being a cloud engineer is by doing, right? It's not by what, it's actions, right? You spend lots of time doing labs, doing hands-on lab, basically testing. That's how you learn. So, picking up today, we are starting with AKS, right? We're going to look at it. It's still talking about fundamentals, but today we're going to deploy things on it. So we're going to use this Microsoft hands-on lab, an example of it. So I'm not going to do a lot of reading. I'm just going to click out for the things that we are going to go today. So today, say, hey, pay request. The pay request, he wants you to have at least the minimum you should have an Azure subscription, right? Again, that's why I say it makes sense for you to get the free tier Azure subscription. We're not for you to get this. Next one is to have a GitHub account because your code needs to be stored somewhere, right? Then moving on. The next one, it makes sense to have a Visual Studio Code, right? Visual Studio Code is the tool for coding. You guys have seen me use this a lot. I can show you guys an example of a VS Code. This is an example of VS Code. You can download this and install it. It's free. But one of the things I want to do, it makes sense to have a Copilot license. So I saw it part of the labs. I felt like something that I'm going to switch someone of it. Instead of doing myself, I'm going to introduce AI a little bit to say, hey, this is what Copilot does, right? You can actually use Copilot to write a Docker file, give you a context of what you're going to use to do. We're going to use Copilot to write a Docker file. So you're going to see how all of them work today, right? Then it makes sense to have Azure CLI, GitHub CLI, Git, because keeps you TL, so you'll be able to type the commands. Docker Desktop. Docker Desktop is very good. Docker Desktop will help you to be able to, with Docker Desktop, it comes with Docker installed, pre-installed. Helm is okay, right? Helm is for packaging applications, customize, draft, and JQ. And they say basically they want you to use the Bash, ZSH, or Azure Cloud Shell. So I'm on Windows, right? I'm going to try to use Azure Git Bash to do some of it. So, but if I run into any issues, if I'm unable to do it, I can switch to my Linux environment, or I can whip up another laptop and do it, or I will look for alternatives. So if you see me doing something outside of what the lab is, it's basically me trying to find alternative because I'm basically running on the Windows laptop, right? Windows 11 laptop. So because this last step say, hey, they want you to run it on Bash, ZS or Cloud Share, Azure Cloud Share through the portal. I can also run through the portal, but I wouldn't want to do this. So the next setup is a setup Azure CLI. So you can go ahead and download Azure CLI. I've already downloaded and installed it, so I'm not installing it again, but you can download Azure CLI by just going Azure CLI, right? Download the CLI locally. Download the CLI, download it locally, install it on your laptop. We don't need to go into this. It's because the same way you install 90 a lot of applications. Download the MSI version or any version and you install it. It's pretty straightforward. So I'm not going to go into that. So the next is saying to log in. So I'm going to set up Azure CLI on my own on my laptop. I'm going to come here and bring it here. So I want to zoom this. I want to make it into split screen. Let me do something so that it should be easier. Yeah, I'm going to do it like for like this. So that way it will be basically split into the screen. So I'm zooming in so people can see more of my screen. So I'm just going to, again, I'm going to do copy and paste, right? The ones I need to type out, I'll type them out. But yeah, this is copy and paste. Copy and paste. So this guy say, hey, login. Easy login. What am I trying to do? I'm trying to log into Azure, my Azure environment through the CLI, right? So it's asking me to go to this URL. I'm going to drag it more to explain. Say, go to this URL and enter this code. So I'm copying the URL. Oh, sorry. I need to do it again. Sorry. I did. So don't do Control C. Control C will terminate the session. I'm just going to do this like this, go this route. All right, it's coming and it wants me to enter this code. This is basically a way to log into Azure with your system. So I'm logging to just AZCLI with my system. Guys, you remember we did this one, we did AZ104. AZ104, we talk about, okay, different ways you can communicate with Azure. You can say we can communicate to Azure through your portal. We say you can communicate through that through portal. We could say we can communicate through AZCLI, through PowerShell. We say also you can communicate. Also, you can communicate through Terraform, right? Through different APIs. Well, right now I'm using AZCLI. So as you can see, it has logged in now. What the next message says is retrieving my subscriptions, all subscription I have, right? It's trying to retrieve them. Let me see. It shouldn't take this long, but let me see why. Retrieving selects this. This shouldn't take this long. Let me use 2. Okay. Let me see. All right. So it chooses this one, the default one. I actually wanted to choose this one because this year I have a lot more free space. So I'm going to do it again. I'm going to do AZ login again. Let me see. AZ login. Let me see. Yeah, connecting. Oh, okay. So what is it showing you here? It's showing you basically, hey, so you have 2 subscriptions, right? Which one will you want to set it as default, right? Think of it like you're making a call. You have 2 SIM cards on your phone. You want to make a call. Which one do you want to use to make the call? That's basically what it's asking me here. So in this case, I want to use the second subscription because that's where I have some resources, some money to be able to try out some of this. So I'm going to go back to this. I'm going to go back to this and this. Yeah, okay. All right. So back to this. So the first step, we have done the first step. It said, okay, hey, this guy, AZ login, we have logged into our system, our subscription. The next is say, hey, we should run the extension, run the flow into an extension. I'm just going to run it again. This is an extension. It's like, you know what the extension is? You're improving what is already what is already have. So if you install AGCLI, it doesn't have the AKS and then AK review extension. So you can add it. So that's basically what I'm doing here. I'm trying to add it to be part of my code, right? So say it's already installed because I already done this. I'm just going to clear the screen. Again, if there's something you don't understand, I'll try to explain as much as possible. If there's something you don't understand, you can just say, hey, no, so can you throw more light into this? I've shared the links to this lab so you can open it like on your system and be looking at it to see whether it will make sense to you. All right. So the next thing I'm going to do, I'm going to create a random variable. What's a random variable? This, if you've ever done IAC, you understand why we're creating random. What's a random variable? Let me explain. Most things in Azure require a unique name. You require a unique DNS name. So for example, you're creating a storage account. The storage account, remember when we do storage account, say, hey, the storage account name is unique across Azure. So if I create a storage account name Nonso, is unique across all Azure environments, right? So what I'm doing here is what I'm trying to do here is what this is doing. This can say, hey, I want a situation whereby the storage account name will have a random variable attached to the end. So that means anytime anytime I do it, the name will be unique. So for example, my name is Nonso. If Dominic creates a storage account Nonso, doesn't matter that my name is Nonso. If I try to create a storage account Nonso, it will not allow me. But I can afford to have a storage account say Nonso 346. So this random variable, we are declaring a random variable to use, right? To use for all our deployments. So for now, you can see is a 5-letter random variable 14227. So if you run this in your own, I believe it will give you a different thing. So the next thing is location. We're going to set up the location. I'm going to set up a location. It said East US. I'm not in East US, for example. I'm going to use West Europe because that's the data center closest to me. Guys, remember when we talk about Azure data center, you deploy it to the data center to the region closest to you. Right now, the one closest to me is West Europe, so I'm going to choose West Europe. So I've already stored this variable. So the next thing to talk about is okay, subscription name. Sorry, not subscription, resource group name. What is the name of resource group? Right? You can see that $ rand in the end. What is doing? I'm attaching random variable to the resource group name. So I'm not creating it. I'm basically saving the variable value. So I'm going to call it AKS class. Just leave it like this, right? So the next thing is basically saying account listing, list the regions, the supply availability zone, blah, blah, blah. I don't think I need to run this, but I can just run it to show you guys. Let me see what it's going to come up with. So these are all the regions available in Azure. Remember our 8900 class, guys. These are all the regions available in Azure. Telling me, okay, hi, you can choose any of this region. Let me see whether there's. I already selected West Europe here. Location of West Europe. Do I have any West Europe? Do I have West Europe here? It's not something alphabetically ordered, so you might have to do a search. I believe it should be here. Yeah, this is it. This is West Europe, right? So that's West Europe. The next step is to create a resource group. Guys, remember our class. They say, hey, anything you're creating in Azure has to be existing inside the resource group. So you can see the next step here is what we're doing here. We're going to create a resource group, right? So see what is doing. We are doing command now. So guys, everything's coming together small, small. AZ group create. AZ Azure resource group create name. The resource group name we defined here, variable here. Remember, right? RG name class, right? Then the next one is basically location, right? Location, we already defined location to be West Europe here. So I'm going to just allow this to run and basically press enter. All right. So the resource group is created. Let's confirm that this resource group actually created, right? So I'm going to go to my subscription, the subscription. You can see saying succeeded, right? So subscription, if I go to resources, no, I should go to resource groups. I can't find it here, right? Can't find it here yet. Let me refresh. Which subscription is this? Oh, this is a different subscription. Sorry, not the one I'm talking about. It should be this subscription. Remember, I selected the subscription I wanted to run on. So resource group. Remember, AKS class 14227. Right? This is what we say. Our random number is what 14227. The resource group name is now AKS class rand. So AKS class 14227. Created the resource group. Now moving on to this, right? So the next step is we need to deploy Azure resources, right? These are the various Azure resources we're going to deploy. Kubernetes, the container registry, and Azure managed Prometheus, a Grafana, Azure Grafana, log analytics workspaces, a key vault, app configuration, Cosmos DB, and a user assigned managed identity. All of them are bundled into this ARM template. So if I click now, you can see the ARM template here. I want to show you the ARM template. So no, this is not the ARM templates. Okay, so basically run this command to deploy the ARM template. This is what an ARM template. If you want to, this is the ARM template you're going to deploy. So if we run this command right now, let me move this guy by the side. If we run this command right now, it's going to create all this. So this is what it's going to create. All these resources are bundling into the ARM template. So we are deploying this using what? ARM templates. Say resources sample. I actually pasted it up, but I'm going to paste it again. Okay, Dominic is already pasting in those, so don't worry, Dominic will handle it. Okay, all right. So next time we're going to do is we're going to deploy our resources, right? This is the link we are going to use. I'll just copy this. Again, very simple. Paste it and run. Press enter. It's going to try to create all these resources in my environment, right? Going to try to create all of this in my environment. Very, very good thing. So again, Azure is learned by doing. Cloud engineering is learned by doing. I don't know how I cannot emphasize it enough, right? So if I tell you today that amount of labs I've done today, not only on this, right? Because I'm trying to renew my Kubernetes certifications. If I say the amount of labs I've done just to get myself ready for that certification, because there's hundreds of labs. So if you want to progress in this field, you need to do labs. You don't just read, you need to do practical. And the beauty about it, most of them you don't need to have an Azure subscription, right? Some you need to have an Azure subscription, and if you are free here, you have 12 months to try some of the resources. So it makes sense for you to spin up those and try those resources. Try it, make mistakes, delete it, retry again. So when you get into interviews, if someone say, hey, have you ever watched AKS? How do you connect to AKS? All those things will be basically basic knowledge for you, right? Why this is deploying, because of course it's going to take a while. I want to show you guys a Kubernetes cluster again, right? This is a Kubernetes cluster. Can someone tell me the function of The etcd. Who remembers? Can someone tell me the function of the etcd? Anyone still remember what the function of the etcd, what the etcd does? Right? So remember, we say a cluster basically is a function of what? Multiple nodes. Inside a cluster, what makes a cluster is basically there are multiple nodes on it. Inside a cluster, we have what we call the control plane and the different nodes, right? The control plane basically does what? Manages the different nodes. So we basically say, hey, the Kube API basically lives on the what? On the control plane. So when you make a request to an application, your application basically hits the Kube API server who directs, does what it needs to do, right? So we also say, remember, we said, okay, hey, your pods. Pods is what is the smallest thing you deploy in the Kubernetes cluster. We say that containers live what? Within what? Pods. Right? Remember, containers live within pods. Okay. If you have run, we say, okay, if you run into issues, if you want to troubleshoot a pod, we say you run troubleshoot with what? kubectl get pods namespaces. We discussed namespaces. The namespaces are like what? Brackets, right? The same way wallets. I used to call it. I used to call it pockets, right? You can have one pocket, right pocket, left pocket, and back pocket. Most guys like to put their wallet in your back pocket, the keys in the right pocket. So that's what namespaces are basically, and that's the same way pods are. Depends on the resources. You can try to create a hey namespace no so should hold no source resources. And we said, because this one nobody's answering, I'm guessing you guys have forgotten. You said that the etcd job is to store the state of things in the Kubernetes cluster. It's like your Kubernetes cluster database. So, hey, say pod node so should be in node 1 or pod node so exists in node 2. Is the etcd cluster that stores it. It is like what you know how your memory card is the memory card, right? That is the database, the memory card of the Kubernetes cluster. That's the function of the etcd server, right? And is available what in the control plane in the Kube API server, in Kube API node. That's where it is, right? You said about the scheduler. Scheduler is basically, hey, you say I want to create a pod. The job of the scheduler is basically say, hey, where do I want this pod to be created on, right? As this guy is running, I want to show you guys something. I want to show you guys the deployment. Let's see what our deployment is doing. If I go to the Azure portal, if you're following along, go to the Azure portal, you can see this is the Azure portal. This is Azure portal. This is where I'm creating. You can see all these resources are being created now, right? You can see AKS cluster, 3SY, app config, my container registry, my Grafana, everything are getting Prometheus. All of that are literally getting created as we are speaking. If you want to see more about them, you can come here and do deployments. Because we're deploying with ARM templates. You can see it's currently deploying even as you are speaking, right? As you're speaking, it's currently deploying. So deployment details, lots more. I'm going to shift this a bit more. Make this okay. No, I'm not going to make it bigger, but this is basically what we're deploying, all right? Server manager identities, a log analytics workspace. Something failed. Mongo failed. Let me see. Why did it fail? Sorry, we are currently experiencing high demand in the West Europe region for these zonal redundant accounts and cannot fulfill your request at this time. Again, okay, so what is guy telling me? Not able to create this guy in this region. Why? Why? Means Azure is kind of full. That region, they don't have enough resources to create it for me. I can as well delete this and put the deployment in a different region. But let me see. Let me see whether we'll get to where we'll use the Mongo database. Maybe we'll not get to there today, but let me see. So I'm likely going to, at the end of this class, if we're not able to finish, I'm likely going to drop everything and we're going to recreate it next week because of what cost, right? I don't have $1,000 on Azure subscription. This is just a test lab subscription, which are just $100. And I believe this literally wipe this in a heartbeat if I'm not careful. So I cannot leave it to run till next week. Okay. So while it's creating, I just wanted to conclude the creation. So it's basically still creating the AKS cluster now. Let's see when it finishes. Or has created every other resource with a pending only the AKS cluster. Okay. Yes, I can create it in another landing zone. Of course, I can create it in another landing zone. That's not an issue. I can create it in another region, not landing zone. Sorry, landing zone is totally different. Sorry for the misuse of words. You can create it in another region, right? Right now, it's complaining about hey, maybe they don't have enough compute in West Europe to create Mongo. They say high demand because more people use Mongo now, use as a vector database for their AI applications. Probably they don't have it. So an ideal thing I can decide to maybe I will choose to read Sweden Central and try Sweden. Maybe I'll be able to do it there. But in the meantime, let me just allow it. AKS cluster has it finished creating? Let me see. AKS. Yeah, cluster has finished creating. What is creating now is the app configuration. All right, let's see. So that's also one I want to bring up, right? You see how I'm able to go to deployments. Sometimes you're trying to create things in Azure, right? I'm teaching you guys troubleshooting now. You're trying to create things in Azure now, and it's failing, but you don't know why it's failing, right? When me ask a question, when me say, "Hey, can the database be replaced with SQL?" It depends on what you want to do, right? Mongo is a NoSQL database, right? Mongo is a NoSQL database. So because it's a NoSQL database, if you want to deploy things that has to do that NoSQL, then you cannot use you cannot replace it with normal SQL. So it depends on the kind of thing you want to deploy. To be honest, or the requirements of your application. If your application are basically the acid, the acid thing, they say, hey, you need is very acid requirement, so you cannot use Mongo. You have to use SQL. But it depends on what the application is. The need of the application would determine what you have to do, what you would do. Let me see. It's deployment is still in progress. Let me refresh. Okay. All right. Cost is already running down. Wow. This was $150 and it's already 91. A few hours. A few minutes, right? So it's already 91. Let's see. Let's see deploying. So far, any questions, guys? Any question, anything you would like me to clarify on? All right. Okay. So why is deploying? I want to be going forward just to explain more, right? Explain more things. So application design and build, right? So we all know what a container is, right? I'm not going to waste my time into this again. Well, I know we talk about it a lot, but we all know what a container is, right? So the next step is basically build a container image. They say we should build with draft, right? I tried to install that draft on my Windows, but it's not working. So I'm going to try to use I'm going to try to use it. I'm going to try and use it using maybe I'll use Copilot to do it. So let me just bring it up. Where is my VS Code? Yeah, this is VS Code. Okay, I'm bringing my VS Code here just to show you guys a little bit of what I'm doing. I'm going to do, right? So Git clone. I'm going to clone this from Git clone. One is already there. Git clone, right? So I'm cloning this application. All right, let's see. Okay, so this is done. Git clone is there. This is the resources application. This is the name of the application. So the name of the application is saying depend bot, right? Let's see. Let's see if you read me. Let's see the readme of this application. Preview. Yeah, open a preview. What is the application? So this application is what a sample airline booking application for demos, get properties, blah blah blah. So these are the steps. If you want to do the application, you want to run it locally, this is basically what you need to run. np get started, cd into it, npm install, npm run this. This is basically how you run this application. And it is, from what I can see, okay, so if you use Azure OpenAI service, you need to create an Azure OpenAI resource, deploy a model, and use this. I'm not going to go through this. Maybe in another lab, when we're deep more into the API, we can do some of this. What I'm going to try to do, to be honest, I'm just going to build the Docker file of this application. Okay, so yeah, I'm going to do cd into this. I believe I'm already into it, but not yet. Contoso air, right? Okay, deployment has failed, right? Has completed, but it failed, right? What is error is showing? At least one resource didn't deploy, and we already know that resource, right? The name of that resource is what Mongo, and we've seen it because of what region availability. So I'm going to leave this for now and just continue on the labs. Clearing the screen, right? Okay, so have a fresh screen. But so far we've done this, but the error we got, we've done this, but Mongo that didn't deploy. So leaving that one aside now. Moving on. The next step is this step, right? We need to do a git clone. We need to clone application, which I have done, right? I guess want me to do it now. The next step is they want me to enter into this and create a Docker file. This draft, if you're using a Mac, you won't have an issue. If you're using Windows, I couldn't find a binary to install it on Windows. So I'm going to find a way to do this step. I'm just going to I'm going to use what name of calling. I'm going to use Copilot to do it, right? So unfortunately, I have the free Copilot here installed on my system. So you can get the free Copilot. So I'm just going to say, hey, looking at the connect, I'm going to tell you connect to SRC. I'm just going to vibe code it right now. So the CD into, oh, there's already a Docker file. What am I saying? There's already a Docker file. Sorry, guys, 1 minute. Please take over. I need to take care of my son. 5 minutes, I'll be back.
Hi guys, how you doing? How's the weekend going?
Yeah, not too bad.
Fine, fine.
Are you guys here last week Saturday or not?
I didn't get that. Please, can you repeat the
I said,
question?
were you guys here last week Saturday, the last week section?
Oh, I wasn't. I think my network was bad, so I couldn't
Oh,
join the class.
Okay, sorry, guys. Sorry for that breaking transmission. Okay, so I wanted to create a Docker file. Fortunately, the Docker file is already created right here, right? But if I wanted to do it, I can as well just tell, hey, feed into this vibe check, create a Docker file. This basically, I can actually do it like that, but I don't need to do it because it's already there. The step here, yeah. Let me bring up this guy back. Our bash file back, right? The step basically says, hey, okay, on the terminal, run the following command to create a Docker file for the application. That create Docker file. We don't need to do this. We already have this, right? So interactive port 3000 and port 22 in Node.js 22. I believe we all have all of this here. Let me see ports. App port, expose port. Oh, okay. Yeah, I see. Expose port, app port number. Okay, yeah, it's already there. So look at it. The app port number is 3000. The node version is 22. So we already have the Docker file, so we don't need to worry about this doing this step again. So this step is already done. The next step is to build the Docker. So you need to build the Docker file. To build it, I'm going to show you guys now. We did this before when we were doing Docker, but I'm going to show you guys how to build it again. So it's not rocket science. You have the Docker file, you have the command here already. So you can just copy it, go to the path where you have Docker file. This is the command basically say Docker build -t means to tag the name of the image. Yes, it was already integrated. So all you need to do is go to GitHub Copilot in GitHub. Sign up is free. Sign up, it's free. Then open GitHub VS Code. Start chatting with it. It's already integrated, and they give you a some free tokens to use every month. I will basically consume my own within 5 days. So, but yeah, you can do that. So the next thing we're going to do is we're going to build an image. To build an image is pretty straightforward, to be honest. Docker, remember I say, hey, when we do Docker, we say the cheat sheet of Docker. The first thing you need to wake up and listen to is what? The first thing, Docker. Once it's Docker, I know, okay, Docker is the main word. That means it's Docker related. Next thing, what do I want to do? I want to build an image. So building that image, the next thing, what do I want to do? The image, what I call the image? The image will be what? Contoso air. Do I want to tag it? Yes, I want to tag it. The -t will help me to what? To tag it. Okay? -t will help me to tag it. Will it be latest? I'm using latest tag, but I can call it V1 or V2. Then these docs specify where your Docker file is located. So for example, now, I want to show you guys something now. So if I try to run this now, if I copy this, sorry, Let me copy this and try to run this here. I want to show you the error. If I try to write this guy here, what's going to happen? What is it? Hey, cannot find your Docker file. That's why, because I don't have a Docker file in this location. So if I do ls now, guys, you can see there's no Docker file here, right? So I need to go to this path. If I want to do this, I need to go to this path. So I can come here and just do, let me see, where's this location in my laptop? Let me see, I need to get the location number, open integrated terminal, no, reveal file. Let me see where I can find it. Just I need to cd into it. Now cd means to change directory into it. Okay, let me minimize this. Okay, here I want to cd into it. I'm going to do cd here. Okay, I hate that I cannot do. All right, so it's cd OneDrive, documents, dev, documents, slash AKS, documents, sorry, these documents, documents, dev, AKS class. I'm going to that path now. AKS class, contour SRC. Right, I'm in the path now. If I do clear now, I want to clear my screen so to make it less confusing, and do an ls web. So I need to enter inside the web, cd web, right? If I do ls, let me see. You can see the Docker file is there now. So if I run the same command we ran before, which is this, Docker build-t, you see it will build now. So it's building now. You see, it's able to find the binary file, is building it now. So again, you can run some of these steps locally. Honestly, you can run some of these steps locally. Right? Like right now, I'm building the image locally. After I build the image locally, we're going to test this application locally and see what the application is about, right? I'm still building it. You say, okay, I'm step 2, step 4 of 7 now, right? So it's basically fulfilling all these steps. See all the steps that is listed here. That's what it's doing. So basically say ag, right? Basically deploying environment variables. That's what this one is. From node, right? Guys, I say, hey, node slim. We are using the slim version because that will affect the size of our application. So this guy is a multi-state build, right? He's using this to build our dependencies, and he's using this one to do build. Instead of copying everything to make my image, this is what we call a multi-state build, right? So if you're interview someone say, hey, because the truth is that you just need, to be honest, I'm only mentioning you just need to get through the interview, because on the day-to-day tasks you get by if you understand the basics. So if you're in an interview and someone say, hey, okay, what do I use to reduce the size of a Docker image? What do you use to reduce the size of a Docker image? You simply say, hey, the multi-state build is one of the steps you use to reduce the size of a Docker image, because it uses different images for the build and the run. So for example, let me use Java for example. There's JDK, Java Development Kit, and JR, the runtime. So if you need to build your WAR files or your JR or your Java files, you need the JDK, but you don't need the JDK to run. So with Docker build, with multi-state pipeline, you can do, first of all, use the JDK to build God JDK image, built in it. The output is now what you now make as your JRE, and your JRE, and it will now be lesser. Your Docker image will be lesser, right? Okay. So it has finished undefined usage of ag port line 22. Oh God, it didn't complete. Let me see. Okay. So you know what? Let me see. Clear. Docker Docker images. Docker image. Let me see. Did it build? No, it didn't build, right? Okay, no, it built. Okay. So this is my image, right? Docker image. See the size was CISO 103 megabytes, right? Okay. So successfully, I will deal with that error later. Let me just leave it. So the next step is basically to run this container locally, right? This step will run container locally. So I'm going to copy this and try to run the container locally. Container is running now. It's running now. Let me test it on this URL. So shrinking this guy a little bit so we can see. Let me see. All right. Oh, so this application now is running locally on my system. Can you see? Running locally on my system. Amsterdam is going to say to ATN to tens. I say ATNs. Wow. My able to add is showing up, right? Okay, so 28. Come back. Let me see. Search for flights. Go to search for flights. This is just a big application, right? So you can build this. So if you finish this lab now, someone say, hey, show me your lab. Show me what does it take to build an application. You understand that. You understand that. You can explain through the process. That's why I said cloud engineering is by doing, right? Right now, we'll build it locally. We'll test the URL locally. Let's see what the next step on the lab, right? The next step on the lab is what now need to, this is Docker stop. You want me to stop it? Let me just stop it. So let me just stop the control. It's fine. All right. So the next step is what? Push the image to container registry, right? Container registry. Guys, remember container registry. Container registry is where you store your image. So there's several places you can store your image. You can store your image in on Docker Hub. But for an enterprise environment, big companies, they don't want the application. Imagine like Microsoft now, their internal application they used to do work on a day-to-day basis. Let me use, for example, my company, NIBC. Our applications, you can go and put the image and use it. No, that image is a company asset. So it needs to be stored in the private registry. In our case, the name of our private registry is what if you go to all the things we deploy, let me go back to the other things we deploy. This guy, resources, container registry, ACR. I can just type ACR here, right? ACR. Come on. Container. This is the container registry, right? Okay, so right now I'm going to try to push this image that we successfully built to contain the container image to ACR, right? Container registry. Okay, so the step is quite simple. ACR login, then ACR push. Simple. So I can just let me do ACR login first, right? Pushing this guy so we'll have some clarity again. Have some more space. I'm going to do a clear so we'll not be confused. Pasting this here, login name. Let me see. What is it telling me? Hey, I don't know ACR name because of what I didn't export the ACR name. It's telling me that it doesn't know ACR name. It didn't declare the variable, right? So of course, saw it on red before. I knew it was going to be an issue. This is how you get all those variables assigned, right? This is how you get all those variables assigned. So all those things assigned. Let me just run the whole of this. If I paste all of this, run now. So the guy say AKS name. This guy is going to go to deployment and get the AKS name. This guy is going to get the resource group name, the ACR name, the Mongo name. The Mongo name we fail. Remember, we're not successful in deploying the Mongo. So I'm just going to go run it like this. Now let me see what happens. If I run this guy to get all of this, all these values. Come on. What happened? Yeah, he's trying to get some of them. It's not getting them. Annoying. Okay, I'm going to do something else. Clear. It's connecting to Azure, trying to get them, and I know some will be an issue. So I'm just going to do this AKS name, right? Deployment show, blah 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 blah. AKS. No, I'm just going to get the names. Sorry, guys. AKS name. This is the same as doing this. AKS name. Go. What was the name of the AKS? Right. Let me call this ACR name. Let me do ACR name first. At least easier. ACR name. Right. Copy this. Paste it. So I've added the ACR name now. Let me try and run this command again. I can do a case name. Well, if I try to run this command again, let me see. ACR, you can see, you've seen how it work, right? Yeah, it's trying to connect. So right, what am I doing now? I'm trying to ACR login. I'm trying to log into the container registry. Saying the what login successful, right? Successfully logged in. Very good. If you come here, the next step on this is basically so as you exported someone asked a question, say as you export the names variables from AZ, is it stored locally? Yes, it's stored locally. If I should close this session now and reopen it, I have to do it all over again, right? So these are stored locally. That's a very good question. Okay, all right. So the next thing I've done ACR login now. The next I'm going to push now. I'm going to run the following command to tag the container tag the container image with the ACR registry name. So I'm going to tag it again, the image I have already, and push it, and then push it to container registry. So I'm going to first of all run this command first to push it, to tag it. This guy tags it. I'm going to use this to push it. This will now push it to container registry. So right now, it's pushing the image to container registry. I'll show you the image now. The image was not locally, was all locally before, but now it's no more. So another option, right? If you don't want to do this step, another option, if you can actually build your image using OCR, right? You can do remote build. It's totally possible, but we're not going to do all that, to be honest. We've already built it with Docker. So if you don't want to use Docker to build, you can do remote build with ACR. With ACR, you can use ACR to build an image. So imagine that step with the Docker build before. You don't want to do that. You can use Docker build to, you can use ACR to build it. That's basically what this guy is explaining. Okay. So the next step, this guy is basically talking about, hey, the different Kubernetes resources, right? It's still pushing. I will show you guys when complete. Kubernetes resources. I know we talked about deployments. We spent time on deployments. We talked about replica sets, right? Remember, I say, hey, replica set deployments, what are they? We talked about daemon sets. The daemon set, for example, if you want it to be available, you need a pod be available on every node. The daemon set is basically used to collect logs, right? A DNS service is sometimes is a daemon set. The deployment is say, hey, you want to deploy your application, no so application. You want to package all the resources, things around the service, the pod, and you want to define the number of replicas you have. You can deploy it using a deployment. And we'll talk about replica sets. A replica set is basically a higher version. Yeah, so a replica set is basically a lower version of deployment, right? So deployment comes to encompass what replica set is doing. Few things that I didn't talk about is stateful set. I said stateful set. I mentioned it a little bit. I said stateful set. I said stateful set a little bit is for storing what. Stateful is basically for storing what. Anything you want to store in the Kubernetes that requires you to save data. So, for example, I give example of a database. Say, hey, you build the application for Piper. Your application is very fantastic, but the application, your database is in Kubernetes. Imagine if I come to register on your application, your database is on Kubernetes. Tomorrow, I register today successfully. I'm using the application. Tomorrow, something happened in your environment. You start the container. Remember, anytime you start a container, it's coming up as a fresh device. So if you don't want it to be a fresh device, you want to reference to the previous data, you need to attach a container to it. See it as ways, hey, anytime your laptop restarts, that laptop is coming as if that nothing is installed on it again. So if you want to keep something more with that laptop, you need to connect your hard drive. That's what a container is. So in this case, a status set, an example of a database, and I can decide, okay, hey, let me attach a drive, a hard disk. So now whenever the container restarts, it will pick it up. It's basically called, that's what a stateful set is all about. Stateful set, that's the type of resource it is. The truth I want to mention is a job and a cron job. These are guys basically, what we know what a cron job is, first of all. Cron job, similar to how, let me just, in your servers, right? There's what's called a cron job. The cron job is basically, hey, you want a task to perform at a particular time. Let's, for example, at 12 midnight every day, I want to restart a particular service in Kubernetes. And so in my server, right? I want to restart a particular pod. How do you implement that in Kubernetes? Cron jobs. Let's say I want to back up at 12 midnight every day. Instead of you coming to trigger that backup every day, you can do a cron job that at that time, Kubernetes automatically knows, hey, that will run and basically perform that task for you. In this case, perform a backup for you. Okay. All right. Please, can you repeat what you mean by stateful set versus daemon set? Okay. Daemon sets. Think of daemon set. Daemon set is basically at the heart of daemon set is a pod. Pod is under a daemon set. But difference between daemon set and a pod is that when you declare a daemon set will ensure that an instance of that daemon set app, which is basically a pod under it, is running on every node. Remember this picture we have here. I'm going to scroll up a little bit to show you guys. So if while this guy is running, I'm going to bring this guy, make it bigger. This is a cluster, right? We have what basically 3 nodes. This is control plane, and this node 1 and node 2, 2 nodes plus control plane. If you deploy a daemon set will ensure that you see, let's say the daemon set is non-so app, is non-so pod. It make sure that the pod is running. That daemon set pod must be run, at least one instance is running on every node. So in this case, I can assume that this pod and this pod are what daemon set. That was the daemon set is. Daemon set ensures that at least one instance of that pod is running on every node. It's mostly used for logging, collecting logs. So think of the example now. Imagine we build an application. We want to know what's happening inside the application by collecting logs, right? By doing observability. That's basically it. If you are doing observability, and imagine that the pod is now running on a different node that doesn't have the application collecting the logs on it, that means it will fail. Like something is failing, you won't get the log. But a daemon set will ensure that the log collection application, for example, Elasticsearch or Bit or whatever you are using, is available on every node. Stateful set, on the other hand, is basically used to store, whenever you store anything that has to do with retaining data, databases, maybe additional, let me say, for example, file logs. Your application, for example, there's some applications, people that .NET application, people that write application .NET a lot, I can confirm that there's some applications that you write. That application needs you to have what they call it again. That application needs to have where it stores files. So, for example, now my application is basically process what. Let me use an application that does receipts. For example, what it does is right, it picks a receipt from our website. After somebody finishes deploying buying, it generates the receipt, give the person, and store an instant in a file server. That case, if I'm in that application is located in Kubernetes, I need a place to store it. That attachment that it needs, I will use a type of stateful set. That's what I would do. Is it clear? Okay, is it clear? Okay, all right. So, okay, all right, cool. All right, so back to what we are discussing. If you see here, you can see our push to ACR is now complete, right? So what we're going to do next is what we're going to do next is confirm whether it's there. This is our ACR. Is it even there, right? Is the image we pushed? Is it the contour air app we pushed? Is it even there? So what I'm going to do, I'm connecting to it. I'm going to go to I'm going to go to repositories. So this is my ACR container registry. I'm going to view all the repositories that are there. For example, now contour air, you can see it's there, right? Successfully there. We remember the image tag we put is what latest. This is the command we put. Let me drag this guy a little bit again. Sorry, guys. If I go up like this, this is the tag I put latest. If I put a V1 now, right? Let me use, for example, V1 or 1.0 now and run it now. 1.0, you can see it will push tag 1.0. Oh, let me see what they say. Okay, it's telling me what that this tag does not exist because I've not tagged it. If I want to build one, I need to build it afresh again. So let me just do something. Docker tag. Let me see. Docker tag. Yeah, I will just call it v1 v sorry 1.0 1.0 targets and then push 1.0. Yeah, it's going to put it if you pre-push it in now. So I also want to quickly explain something. Guys, you notice that when I pushed latest, it took a long time. But when I pushed 1.0, it didn't take a long time. It's already there. So if I refresh this guy now, you see 1.0. Can somebody explain what happened? All right, just because of time, because we still have more 15 minutes. What happened is basically caching. Because it's already cached. So Docker is very sensible to avoid you repeating data. It's very sensible not to push replicated data. So you basically use, okay, hey, this layer is cached, this layer is cached, this layer is cached, this layer is cached. Oh, I'm just going to push. I'm just going to say, just going to tag it. You don't tag that change, I'm just going to tag it. All right. Okay. Moving forward. So the next thing we're going to do is we've done this, we've done this, we've done this, moving on. Next thing we're going to do is to get the AKS credentials, right? So I'm going to do get AKS credentials now. Clear. So I need to export the AKS name. Where is my export command, please? Export name. I'm going to call it AKS name. I'll come to this place. I'll come back to this place. Go to repository resources. I'm going to type Kubernetes, the AKS. This is the AKS cluster. So I'm going to come here. I'm going to copy the name, right? This is the name. Come here, delete all of this. I'm trying to verbalize. I can pass it one after the other, but it's more cleaner this way. Yeah, UT. Yeah. Oh, Leo, very good question. Leo said, hey, last week, Dominic used Terraform to create only AKS, right? In this case, I used ARM templates. So let me rephrase. Leo asked a question. So last week, Dominic used Terraform to create only the AKS cluster. This case, this today, I use ARM and I created several resources. What's the difference? There's no much difference. In Terraform, you can see define the number of resources you are creating. In this case, in ARM template, if you look at this ARM template, this raw ARM template, you'll see both the Mongo and everything. I can decide to modify it and deploy only the things I want. So it doesn't really matter. The beauty of infrastructure as a code IAC is that you can look at the code and say, okay, this is what deploys. Like, for example, now, if I share this code with you and you're in the environment, it's going to deploy the exact same number of resources, right? That's the difference. There's no much difference. The difference is basically you define what you want in IAC. In IAC, I can say, hey, I want 10 AKS clusters. So whether it's Terraform or ARM template, doesn't really matter. What matters is what you define inside there. That's what really matters. Okay. All right. So I'm going to run this command. I'm going to run this command now. Where was I? Here. I'm going to run this command now to get the AKS config. So running this command now. Let's see. Going to connect. Okay. So it's getting it and it's saying that the context view has changed. Remember, I have a local AKS cluster. So it's changed context. Whenever you get context in AKS, think about, okay, if you have multiple clusters, now how does it know which one to communicate with, right? This is what the command do. Context, that's how you change the particular environment you want to connect to. So this is the AKS config file. Of course, at the end of today, I'm going to delete this. So hackers that are trying to hack me later will probably not say it if they try. Right? They won't meet it. Just 10 minutes after the class, it's no more available. All right. So if you want to interact with the AKS cluster, these are the various commands you can use to interact. I'm going to clear the screen to have a more fresh look. So you can use this to see the APIs available for you. kubectl API right now. You can use the kube explain to explain a deployment. What's the deployment? Right. If you don't understand, you want to understand, you want to understand a particular AKS resource, you can say, for example, this is a deployment. It's explaining what the deployment is, what the fields should look like, right? Remember when we do YAML, you can look at the fields, what the fields will look like. You can do recursive to see all the flags available. I'm not going to run all of this in your personal environment. You're going to do it. You can do it yourself. So the next step is basically we're going to go to create a manifest, right? Manifest YAML files. So guys, make dir, make a folder. We're going to make a directory. we're going to create a folder, make a directory that will call manifest. So I'm just going to do this. I hate when I copy and this thing happens. Manifest, right? We create a manifest. So the next, I'm going to create a deployment, right? Create a deployment and I'll put it to manifest. So this is what I'm going to do. I'm going to show you guys this, what we just did now. So what the guy is doing is using imperative method, create a manifest. Create a manifest and do a dry run and store the output, right? Store the output. So see, the kubectl create deployment contoto air. -image, which image will you use? Remember our image, right? Latest, using the latest, I can change it. Say the port should be 3000. Dry run client, dry run go to client. Yes, dry run means not deploy it. Sometimes you are seeing dry run means not deploy it. Output it as YAML and store it in manifest / contoso air. That's what it's doing here. I'm going to allow it to run. That's run completely. Let's take our VS Code to see what this guy did right now. This is the manifest. This is it. This is the manifest. This guy will run and just created this. Just created this YAML file for us, right? So that's the beauty about Kubernetes. You don't have to, with OYAML, right? With OYAML sometimes, or with outputs to YAML, you don't have to cram all of them. You don't have to cram you don't have to cram the steps. You can generate what we call a boiler template. People that have do web development will understand what I mean. A boiler template for you to use to continue to, you cannot edit, because some people it's easier to edit than to create. So with this, you can create something. So if you want to create a deployment, sample deployment, you can create it. Okay. This is basically an explanation of what just happened. Basically, I've showed you guys already. So now let's apply this on our environment. So I'm going to run this deployment, right? Apply it on our environment. This guy running now to apply on our environment. Let's create a deployment. Let's do get deployment. I'm going to clear the screen, to be honest. I like having refresher. Right, say, hey, control edge successful, right? You say 1 of 1, right? It's ready. All right, let's do get pods to watch. Get pods to watch is a way to, if it's plenty that is deploying, you want to know that the pod is running. As you can see, it's running already. If it's not running, you need to continue refreshing. So if you are doing deployment and you want to watch it, confirm that it's completed, you is -watch. That's what you use. Okay, but I'm going to it's successful. I'm going to do Control-C to terminate. Next thing I'm going to do now is to do port forwarding. Port forwarding. Okay, sorry. Leo asked a question. I'll just answer with a question before I move forward. He said, hey, please, is cron job automation? Because you mentioned it's scheduled, not clear. Okay, yes, cron job is automation. It's as old as time. So for example, now let's say, hey, have a script that backs up a database. I'll use that example a bit. So normally what I should do is, and I want the database up by 2 p.m., 2 a.m. in the middle of the night. Normally what I should do is I should wake up in the middle of the night and run that script to back up the database. But if I don't want to be there running the database, I can create a cron job and say, run this script by 2 a.m. Monday to Friday every week. Every week, sorry. Every day, Monday to Friday by 2 a.m. every day. If I create a cron job, it will run. This has always been there in Linux. So cron job has been there in the whole end of time, right? It is as old as Linux. Cron job has been there. So Kubernetes now has like a resource called cron job. So if you want to run something in Kubernetes at a particular time, you don't need to run it all the time. You want to run it at a particular time, you need to create a cron job resource and to do that. That's what they call the cron job is all about. Okay. Good. And if you have more, if you don't understand, please just ask the question again. Ask more questions, I will explain. This guy have 6 more minutes. I'm hoping to stop here. We'll continue next week. But before I stop. The next step, remember when we do Docker, when we use Docker, one of the things we do Docker would be the Docker ports, basically to show locally, to show it running on a Docker. Now we want to show it locally running on a Kubernetes cluster, AKS cluster, for example, for that matter. To show it locally on an AKS cluster, we use kubectl port forward. That's what we use. So kubectl port forward will show you running on it. We'll spin up this pod now and try to run it locally. So on our browser now, if I go to this URL now, which is same as localhost, you can see the application is running locally. That is receiving traffic. That's why it's changing this. This application again is running. So most times you deploy an application just before you even do services, do ingress controller. You can even test this application. Either work a day or it didn't day. This is how you do it. Okay. All right. I'm going to stop here and just give you 5 minutes for questions. We'll continue with this next week because I really want to go through the series. I want everybody to just, like I said, Kubernetes, you don't learn Kubernetes by just, Yemi is raising his hands for question. Remy, go ahead and ask your question.
Yeah, so good evening. So I have a
Good
question.
evening. Okay.
I wanted to ask is, are you using port forwarding because it was running on a different ports before, and you want to run it on the ports in AKS? And what is the most number of nodes you've run in your day-to-day work?
My day-to-day work. Okay, so
Yeah.
okay. Yeah, you're going a bit deeper, but I'm going to explain. So I'm going to explain. The first question, can you just repeat again? You said how is it port forward because of what?
Port forwarding was the port different in AKS? Was the port different in AKS and you're using port forwarding because you want to deploy it to AKS? That was it.
No.
Basically,
Okay, so
why are you using port forwarding?
port forwarding. Okay, I'm just using port forward. Port forwarding is just a way to test out a pod that you are running. Same way we did Node, we did Docker. If I still remember it, I'm trying to get it. Docker, pushing up again. Where is it? No, I'm past it. Where is that Docker command? Docker. Yeah, Docker run. All right, and this. It's a way to run it locally, right? Whenever you have port forwarding, what I'm using port forwarding, I just use port forwarding to test. Okay, I was able to build and test locally. Am I able to build as I push it to Kubernetes cluster? Now, am I able to test it in that pod? Right. Remember now, this is now a pod.
Okay, is
right?
it like is it like you're applying the file to run the deployment? Is that what it does?
No, the deployment is already run, right?
Okay.
If I do kubectl, just come down, I'll explain to you, sir.
All right.
kubectl now, get deployments, right? Let me show you. Get deployments. It's already, this control set deployment is saying one-on-one ready. If I do kubectl, get pod, right? You also see that it's already running, telling me it's already running, one-of-one running. So, but, okay, it's running. How do I even check? Now I'm going to access the URL. Of course, to access the URL, like I'm building great, build a service.
Kanye as the badge's former friend, and people laughed out of spite.
Okay, I'm meeting you. You're hearing some voice coming from your background. Dominic, just in 1 minute, I will give you over to you. Let me explain first. Okay, so but the whole idea of port forwarding is like, okay, hey, how do I test this port that is even working? It's just test locally. So the port 3000, I can do port 3000 to my port 80. I can do port 3000. I already know that the port is running on what port. I already know that the port is exposed on port 3000. If I want to find out more, I can do kubectl. If I want to find out, we're going to troubleshooting now, which is a series I was hoping that we'll get to. I can do kubectl, edit, or describe to find out the pod is being deployed on. Describe pod, right, and goes to this. I can actually describe the pod.
Okay.
Right. Let me see what I can describe the pod. So whenever what I'm doing, the whole idea of port forwarding is to check, is this guy running successfully on my AKS cluster? Right. The same way I checked whether he's running on pod, is he running successfully on my AKS cluster? Right. If I look into this, I should be able to see the port. Is it not defined here? Funny enough, it's not defined. So it's not defined here. So using the default one, if it's not defined here, to use the default one you define in your images, which is 3000. So I can also do it. If you look at the Docker file again, you could see that. Okay. Oh, it's actually defined here. If I edit container port is on 3000. On the Docker file, it also states what in the Docker file, it also states that it's 3,000, right? So I can decide to do, let me do port forward now. Let me show you something. I can do port forward and do, I can decide, okay, 3,000. No, exactly sure. I'm trying to remember, but I can do 3,000 to what? To, let me see, 80.
Oh.
For
Yeah,
example,
you
now.
can use 8080 and forward to port 80.
Yeah, you can port forward 80. So it's basically say from, hey, so if I refresh it now, you see that this one will fail, telling me that it's not receiving connection lost. But let me put it again. Changes to 80. Come on now. Why are you terminating? Okay, sorry. Do I'm missing it. Sorry, guys. Let me show you. I'm doing the other way around. It should be 3,000 here, then 80 here.
On the other side.
Yeah, it always confuses me. I think Docker, you do like this, but this, so it always confuses me. Yeah, he always confuses me.
Okay.
So that's just basically. So anytime you see port forwarding, is a way for you to do tests, test out locally. You can, of course, you can give it like this for people. People cannot browse it. But the developer, you're developing, you want to test out the application the same way you test out locally. You deploy on AKS now or Kubernetes now. You need to test it. This is how basically you do port forwarding before you're talking about doing the ingress results, doing certificates and all those things. This is a way just for you to test out your deployment.
Oh.
Okay. So guys, any questions? So that, or anything, Dominic, anything from you? So we can wrap up
Yes,
today.
yes.
Go
So
ahead.
let me just add up to what you have already said. So basically, when Nonso was talking about port forwarding in Azure Kubernetes service, basically is like you port forwarding in AKS allows you to kind of like access a particular pod or a service running inside that Kubernetes cluster from your local machine itself, without you exposing without you exposing it to externally through a load balancer or a node port or ingress, like Nonso have said.
Yeah.
Right. So
Yeah.
if, for example, what port forward will do is it will create like a temporary tunnel from a local port,
Exactly.
from a local port to a port inside to a pod itself.
Mm-hmm.
It's like creating a tunnel so that tunnel will pass, so that resources or service, anything will pass through that tunnel to a pod or services itself. So what he has already said, it's like it is allowing port forwarding is like allowing it allowing you to access a particular pod or a service running inside Kubernetes. So what does it mean? It means that it's not going to be run Kubernetes is not going to be exposing resources externally via through a load balancer or a node port. So imagine if you have configured Argo CD, for example, inside Kubernetes, because Argo CD is like an add-ons in Kubernetes. When you create Kubernetes and then you add Argo CD, right, it will port forward it where Argo CD will not be exposed externally, which means Argo CD, if Kubernetes is not powered on, Argo CD will not run. I don't know if you understand.
I'll tell you what I got. So what I got is if you've done your deployment and you want to test locally, you run the port forwarding. Basically, what I used to do before was I'll get the IP address of the instance I'm running of the maybe if it's AWS, or I'll get the public IP and then the ports, the ports where the container is running on the Kubernetes cluster, and put it inside the URL. It will bring up this Cortoso air like that. But this port forwarding is actually, if you just have to run the command and it brings it up. So this is the simpler way. It makes sense this way. Yeah.
So let me ask you one question. When you are setting up Kubernetes, do you set it up publicly or private?
I don't understand the question.
When you are setting up your Kubernetes for
Kubernetes
your
cluster.
organization, yeah, your Kubernetes cluster, do you set it up privately or publicly? Which one?
Sorry, I don't know the answer to that question. I'll tell you how I've set up Kubernetes clusters. I've run Kubernetes
Okay, so how have
clusters
you been setting
on
it up? Have you been setting it up privately or publicly?
I don't know the answer to that question. Sorry.
Okay, so let me quickly, because of time. So in any scenario, once you are setting up Kubernetes, by design, Kubernetes is not supposed to be exposed publicly. It is never supposed to be exposed publicly, because if you do that, you have flawed your security system in Kubernetes. And anything can happen. Your resources can be breached within a very short time. So by design, it's supposed to be deployed privately. Kubernetes is supposed to be run privately, and then you can use maybe like other services to connect it, through that Kubernetes. Because once Kubernetes is set, if you are running a test format, for example, you are running a sample test, or to do like a demo session for the team and all of that, it is advisable you can simply do like a public deploy through Kubernetes, because you don't have any tangible resources that is running live in production, right? It's for testing purpose. I mean, you run it in dev. So if you do that, it's going to kind of like, it's understandable that this is for testing purpose, like running it in dev. But in a production grade environment, by design, Kubernetes is not supposed to be run publicly, because if you do that, you have flawed the security system in Kubernetes, and that's might put the resources or whatever organization in a very big risk.
Okay, thank you.
Yeah, thank you.
Leo has a question.
Any more questions?
Leo, did you say you have a question?
You said something. Say, hey, is port forwarding for local testing only, private using cluster IP? It's not using service at all. It's not using any type of service now, because we've not deployed the pipe service. Right now, it's not using any service. Right now, it's just testing your port deployment. Right now, it's not using any service. It's not using cluster IP. It's not using, basically, you can say it's using node port locally, but it's not using any service at all at the moment. Very good question.
I have a follow-up question to running Kubernetes privately. So running privately means like if you're deploying a Kubernetes cluster, you're probably deploying it inside your networks, right? Inside your firewalls. So that you're not exposing it to the you're not exposing it to the public. You're not exposing it to the public. But if you're if you're running it through any cloud provider, you're probably running it through a VPC, right? So that way you're not.
It's going to be a VPC, correct?
Exactly.
Correct. I like the way you think, Lemmy.
Thank you. But if you're running it through your hard metal, if you're running through your hard metal, let's say
bare metal,
your bare metal, So, but you'd have to have other networking devices in place to actually hardwire them so that you're not exposed. Maybe your firewalls and things like that. Is that correct?
Yeah. That means you have to, if you are doing a bare metal, that means the same thing that the VPC, the VPC cloud provide for you. You need to get your own firewall. You need to get your own, basically public IP. You need to worry about all of those.
Okay, but if you have a client-facing application, you need to expose that to the public, though.
So if you have a client-facing application, there are several ways you can do it. So that's where the ingress resource comes in. So with the ingress resource, right?
Okay.
You can permit your private IP address and do nothing to a public to an internal IP address that will only match the ingress resource. So the whole idea of private and public, I want you guys to note is basically the Kube API, the Kube Control Manager. Is it over the internet or is it private? So if it's over the internet, then it's public. If it's private within your VPC, it's public. Is private. If it's over the internet, if it's not within, is public, right? So in the case, if you have a private, let's say for example, I have a private facing application and I want to host it in Kubernetes. If I have a public facing application, I want to host it in Kubernetes. If I put it inside Kubernetes, I'm going to have a Kubernetes of type ingress. I'm probably going to have a private IP. Then on my firewall or my front endpoint, I'm going to create a public IP address, which is likely going to map the domain of where I want to export it, and do some natting, soft natting, and say, hey, if you use the private IP address, if you use public IP address, let it translate to a public IP. If you use this public IP address, let it translate to a private IP address within my cluster that matches Kubernetes only on this port. That's where the whole in Azure you can use application gateway as your English controller, or you can use the whole certificate thing. You can configure all of that. You can use traffic to do that. But the whole idea for you to do, you need an English controller to can expose only that to a. So for example, now I don't want to go too deep into this. Let me just summarize it like this. You can expose, even though a cluster is private, you can expose the endpoint to the public, but they will only be able to come on the port you allow it. In this case, like 443, you can say, okay, hey, let port 443 on the firewall translate to port 3000 within my cluster. Let me just wrap it up here.
I think we need a different session on ingress and egress.
Yeah, we need to do a session on ingress and ingress. Let's see how far I can drag this section, because this is already the fourth week. Yeah. So we need to. It's because when you talk about ingress, I think it can come in. They talk about MTLS, certificate management. How do you renew certificates? For example, if you listen, how do you renew certificates? Does it mean at any time the certificate expires, I have to command manually, or can my application be triggering certificates renewal on its own? There's a lot of things there that I'm getting our maturity before I start throwing those bombs.
Yeah, we'll pick it out bit by bit. Let's understand what it does first, then we can expand on it.
Yeah.
But yeah. Thanks for this session. That's really nice.
Thank you.
Cheers.
Thank you, everyone. Any more questions, or we should conclude?
Yeah, I think we should conclude for now. We'll continue next week again. CJ, over to you, please. I don't know if you.
Hi guys, it was a really interesting section. Thanks, Noso. It was quite engaging and lots of good stuff from Kubernetes to take away. Like I mentioned last Saturday, we'll be starting off a section on AI using Microsoft ecosystem. So
yeah,
that's something you guys can look up to. So we still need to round up this AKS training out before we can commence with AI using tools like Azure Foundry, MCP, how you can set up MCP, model concept protocol on Azure environment, and also how you can use copilots. So a mix of no coding and no coding in an AI environment using copilots for people who have Office 365 experience and for people who have coding experience using Azure Foundry. Thanks, guys, for joining. It's a pleasure. Leo,
thank you all.
Has a question.
Oh, Leo, you have a question?
Yeah. Good evening. Thank you so much for this section today.
Thank you.
Well, it's a question outside the scope of today's class.
Okay.
I just want to ask, because I looked at your profile, also Dominic, and who goes on. I can see also is a platform. Dominic, I think, cloud architect or something, and AI and all of that. So I want to ask, in a career path, so how do we navigate it? So that's why I said it's outside the scope. Is it that this whole is a background, or we start navigating into a separate career path? I want to understand how do we navigate into a career path. Thank you.
Yeah, very, very good question. I like what you asked because I've seen it. So what I can tell you is I am a platform engineer currently. My previous role was a cloud engineer. I've been a cloud DevOps engineer. I've also worked as an architect. That's why if you watch what we're doing, we're not we are doing basics. Understanding the basics really matters. So, for example, I'll say, hey, go and learn Linux. Understand Linux very well. Go and learn what our 8900 and 8104, because if you understand those, right? For example, now today I apply for a job in Essential, right? Essential role. Am I talking? I was still recording. Dominic, you have to scrap this car out. So, scrap it out.
Okay. Yeah, I think
please.
you need to stop the recording.
Yeah,
you
please
need to
stop the recording.
Yes, stop the recording.
Or you know what, Leo, we can detail offline or maybe next week before we start recording. But if you have these basics, right? If you have these basics, right, you can better do most of these roles. You can do cloud engineer, platform engineer, the name. Most times you look at the JD, you can see the JD is still the same thing. I've seen some architect roles that doesn't require you to do coding at all. You can confess of that. But I've seen some architect roles that will come, they will still be throwing deployments to you, expect you to do deployments. So what I will say, learn the basics, understand the basics. You can start with, hey, cloud engineer, see cloud engineer role you apply. But most times beyond what they put on the title, look at the requirements. Some will say, okay, hey, do you know ARM? We just did ARM now. If you do a few more deployments, like 10, 15, 20 more deployments, and look at ARM template, you understand ARM code, and you can explain it. You can deploy. You don't have to understand every syntax. You can use Copilot to write those syntax, right? Not GPT Copilot, you can use it to write those syntax. Oh, you need to do Terraform. Understand the basics of Terraform. Understand how Terraform writes its code. You can put it as part of your CV that you know Terraform. During interview, you can do it, you can demonstrate it. The whole complex out of it, you can use your, again, compared to when we started, right? To what we have now, to be honest, it's easier. It's much more easier to enter into these fields, right? It's much easier to enter these fields. You need to write a Python code. So far, you have a basic understanding of, if you are 3/10 on Python, you can literally write, come in as a Python and write on Python script that you can use to automate. If you see, for example, now let's see Kubernetes now. I've not talked about status sets before. I think I've talked a little bit likely. There are some other resources that are probably won't get mentioned in this class. But if you understand how to do kubectl get, kubectl apply, you can literally go deeper based on your requirements, right? So that's why if you notice this class, this class is started in September. What we basically on is understanding the basics. So those basics are going to form into whatever you are going to do in the future. Okay. All right. Any more questions?
Leo, I think we can talk about this after in the channel.
Archie has a question.
Okay, that's fine. Thank you.
Amarachi, please go on.
Hi, good evening.
Good evening.
Thank you so far for the lecture. I want to make a request, right? Sorry, I've not been joining the previous class, and it seems like I'm lost in the old training. So, can I get a previous recording of this class so I can catch up with the next class?
Yes, they are all on YouTube. Dominic will share the link at the end of the class. Or let me even try to get in. We'll share the link at the end of the class. Yes.
All right, thank you.
And again, if you don't understand anything, the WhatsApp group, you can just send us a message. Promise within 24 hours or 48 hours most I will respond. I'm not be able to respond immediately, to be honest. But within 24 hours or 48 hours, I will respond. That I or Dominic or CJ will respond. Yeah.
Okay.
All right.
And also,
any more questions, guys?
Yeah, feel free.
Sorry,
if you
guys.
have any questions or messages, you can feel free to drop message in the channel, and they will respond to you accordingly, just as Monso have said.
Okay, guys, I hope you have a nice weekend. Thanks for being here. It's a pleasure to have you guys again. Thank you, Naso. Thank you, Dominic.
Thank you. Thank you, profs.
Bye,
Thank you very much.
Yeah,
Thank you.
Thank you. I appreciate it. Thank you.
Thank you.
Thank you.